Two pieces of technology you'll use. We talked about Desmos, and we'll just remind ourselves how that works, and then I'll show you how to do it on the TI-84s. With the new operating system on the TI-84s, it's really very simple to do. And then we'll look at a couple quick applications, and then you should have a little time today to maybe actually get a little work done at the end of class. You have a little work time, okay? So piecewise functions, right? Recall that piecewise functions are functions that have different pieces, meaning different functional behaviors defined on different parts of the domain, right? So there's always going to be, each row corresponds to a piece in a piecewise function, and there are two pieces of information for each piece. There is the equation itself and then the domain where it lives, okay? Remember how we did this in Desmos, right? In Desmos, if I want to graph a piecewise function, here's the protocol. We're going to define the function f of x equals, and then everything goes in script brackets. Each of the pieces is separated by a comma, and for each of the individual pieces, we enter the domain first. So, for example, for this top piece, we would do the domain first. X is less than or equal to -2, colon. You put a colon separating the domain from the function, colon 2x. Middle row would be x is greater than -2 and less than 4, colon, -1 minus x, etc. And if I do that, it's going to give me a graph like this, right? And then remember, the other thing that's kind of handy, maybe I'll run through this one more time with you here. The other thing that's kind of handy to do with Desmos in situations like this is to graph the endpoints, so you know where the closed endpoints are, right? So if I do this piecewise function, got to be quick. Okay, so there's the picture I get, right? Is that right? Did I do that right? Yeah, I guess I did. I just got to hit that. There we go. So if I hit, yeah, there's our picture of our piecewise function. And then in this case, the boundaries are at -2 and 4, right? So those are the places where we're going to want to know what the endpoints look like, okay? And I could even do, yeah, right, -2 and 4. So then I'm just going to graph the ordered pairs. -2, comma, f of -2. And then I'll put a comma after, I'll put a comma after that ordered pair and do another ordered pair. So I can graph multiple ordered pairs in the same row. 4, comma, f of 4. And that's kind of nice to do because now it shows me where all the endpoints are, right? I can see that those are the closed endpoints. Every place else is an open endpoint. So that's, like I say, that's a fairly handy thing to do. Okay, I'm going to use this picture rather than the other one. It's a little better picture. It's got the endpoints in there. Let's get rid of that. Okay. Questions on Desmos? Give me 1 to 5 on that. We good on the how to use Desmos to graph piecewise functions? Okay. Probably takes a little practice. You'll get a little practice.
I have a question.
Yes.
So are we learning this to know how to solve the equation, or would there be like a statistic? Like, would this ever help you
Good.
find products and like that sort of stuff?
Okay, yeah. Is there an application? What you're asking? Yes, there is. Remember, and I think the one we talked about last time, just sort of in the abstract, is a good one. Remember, we talked about your height when you're skydiving is a function of time. How if you wanted to treat that as one function, you'd have to break it into a bunch of pieces because it behaves very differently depending on where you are in the fall. We'll look at a couple other examples today, Kendall, that'll kind of illustrate how this could be useful. Okay, let's try this with a TI-84. So with a TI-84, this is actually pretty easy to do. It used to be much tougher to do, but now with the new operating system, and if you don't have the new operating system, which is on the color editions, I think it said 5.4, right? You can always go onto the TI website and check what the latest operating system is. And if you don't have it, put it on your TI-84. It makes a big difference. Each of the new they don't update it very often, but when they do, it always adds a bunch of really good new stuff for your TI-84. Okay, so the way we would do this graph this on a TI-84, we'd go y equals, and then I got to remember how to do this. We're going to go to the math menu, and we're going to go clear down to the bottom. So I'm going to hit up. I'm going to hit the up arrow to go immediately to the bottom of the list, and look at that right there. How about that? Piecewise. It's item B. So if I hit piecewise, it asks me how many pieces, and I can just use the left menu or the left arrow and the right arrow to change the number of pieces. Well, we want 3, so I'm going to hit OK. I just moved. I scroll down to OK and hit Enter, and there's my piecewise function. That's pretty cool, right? I can see all 3 pieces of it, and then I just enter it exactly the way it looks. So I've got 2x on the domain. X is less than or equal to, and you may not remember where to get to that stuff. To get to all of the inequalities, as well as the ands and the ors and all that stuff, the logical stuff, you just go second test. Okay, it's the test menu. So second test, and there's my test menu, right? There's all of the possible inequalities. Well, we want less than or equal to, so that's number 6. Less than or equal to -2. Now I'm going to scroll down. Next piece is -1. I have to use the negative sign, not the minus sign. -1 minus x. And that's where, okay, now for this one, I think I have to use and. I'm pretty sure. Let me just check something. I already did this once before. Oh, no. Huh. That's pretty cool. You don't have to anymore. Don't have to anymore. That's really good. Okay, so I can actually put this in as a compound inequality. I can go -2 is less than, and there's no shortcut to that. I have to go through the test menu, unfortunately. So I go second test 5 x. So x is greater than -2 and less than 4. And then the last piece is -3. Y is -3 when x is greater than or equal to, so 4. 4. There we go. And if I hit zoom 6, there it is. Okay, how about that? Now, the only disadvantage of this is you don't see the endpoints, but I wonder if we could do that. That's kind of an interesting question. Could we do that? I don't know if it's worth it or not, but I think we can. I don't want to waste any time on this, but I would kind of like to show you if it's possible. I think if I go up to, I can do this, okay? If I go up to plot 1, I have to set up plot 1. So I'm going to go, I'll go ahead and turn it on. But I have to set it up. So I'll go second stat plot, and plot 1, it's on. I want it to be a scatter plot, L1 and L2, okay? let's edit that. Uh, Okay. For the Y list, I think I can do Y2. I'm just kind of playing around here. If this doesn't work really quick, I'm not going to waste your time on it. But if I do alpha and I go over to, oh, it didn't work. I might have to mess with this next time. There we go. So if I go Y variables, if I go Y1, how come it didn't put it in? Huh. Say it again. Yeah. Oh, so it's not showing up on yours? Okay, that means, I bet you that means you need to update your system. Okay, which you have to do through the TI website. Okay, and it's I can't remember all the details, but if you go to the website, it'll tell you how to do it. You have to do it on a computer. And you have to. There's a USB cable that'll hook up to your calculator, and you can download it that way. It used to be when we were all in the same room, we could transfer it from calculator to calculator and make sure everybody had it. But now you're kind of on your own a little bit. Okay, I'm not going to mess with this. I think it's not worth it. I'm just wasting too much time. I'll figure this out, and if it's anything that's that important, I'll show it to you next time. How's that sound? Okay. So here's a quick summary of what we did. There's a keystroke history. So if you start from everything cleared, these are all the keystrokes you would hit to get this to work. And then it shows you what the Y editor should look like, what the graph should look like, and then there's our window. Okay. All right, and here's just a bigger version of the keystroke history, I guess. I was a little overkill maybe. Okay, so let's look at an application here. Kendall had a good question about an application. So here's a situation where a piecewise function would be useful. When you're calculating tax rates, oftentimes when you look at a tax table, it'll be broken up into separate rows, and each row corresponds to a different tax rate, right? So generally, the bigger your income in general, the larger the percentage of the tax you pay. But you only pay that tax on the amount over a certain amount. So for example, for the first $7,500 of your income, you are just paying 11%, straight 11% tax. Okay. Once you get over $7,500, so between $7,500, if it's over $7,500 but not over $30,600, then you're going to pay $825, which is 11% of $7,500. You're going to pay all the tax you would pay for $7,500, plus you're paying 17% tax on the amount of your income that is over $7,500. See what I'm saying? If you make over $30,600, so between $30,600 and $74,300, you would pay all of the tax that you would pay at the top of the last tax bracket. If you made $30,600, what would that be? Well, that works out to be $4,752. Plus, you're paying at the 25% rate on the amount of your income over $30,600. So you're only paying at the higher rate for the amount that's above, that's in excess of the previous bracket. Does that make sense? Okay. So we got to come up with a piecewise function for that. I mean, we could do a couple little calculations too. Maybe let's do that first. So what if you made $6,000, then in fact, here, I'm just going to copy this thing. Let's just make sure we understand how to use this first. Okay, so if I made $6,000, how would I calculate my tax? Well, that's just in row 1, isn't it? So it's going to be between 0 and 7,500. The tax is this amount, which is 0, plus 11% of the amount over 0. Okay, so that would just look like for an income of $6,000, it would just look like 0 plus 11% times $6,000, which would just be what, $660. Okay. What about an amount like, let's say, 50,000? Well, that's going to put us in this row right here, isn't it? Right. So if you're making 50,000, that's between 30,600 and 74,300. Then you're going to pay this amount. So it's going to be 4,752 plus 25% of the amount in excess, the amount over 30,600. Okay, so 25% is 0.25. But how would I say this part? How would I say the excess over 30,600? How do I say that? 50,000, I have to figure out how much is 50,000 in excess of 30,600. How would I determine that? You're right. Okay, it'd be X. In our case, X is 50,000, right? So we're actually putting in a specific value. So it would just be whatever we get when we subtract 30,600 from 50,000. Right? And so if we made that calculation, what are we going to get? It's going to be 4,752 plus 0.25 times, what's that going to be? 19,400. Which is going to be, what is that, 97? So that's going to be 4,850. And so that's just going to give us 9,600. Okay. Oops, did I do that right? 49. Did I do that right?
Yeah, it's right.
Okay. Okay, everybody good with that? So let's set up our piecewise function then. So first, we've got 4 pieces to this function, right? Because there's 4 different behaviors in this tax table. So what's going to be the equation for the first piece? What are we going to get for that? What do you think, Sarah? What are you going to do for the equation for the first piece, row 1?
It would be 11% of the exit.
There you go. So 0.11x. Okay, and what's the domain for piece 1? Rebecca Edmonds?
It would be however much over it is.
But the domain are the values of x that we're inputting, right? X is our income. So what about this statement right there at the beginning? What's that telling me?
What the income is?
Yeah. So what incomes? The first row in the tax bracket applies to what level of income? X is what?
It says greater than 0 and less than 7,500.
There you go. Okay. And I could probably dispense with that greater than 0 part, couldn't I? Right? I mean, I could probably just say X is less than or equal to 7,500 if I wanted to. Okay, row 2. What's row 2 going to look like? Other Rebecca, what's my equation going to be here? So how much am I paying in row 2?
Would it be 0.17?
0.17 is the rate, good, times the amount over 7,500. So how would I say that? If X is my income and I only want the income in excess of 7,500, so like if X were 10,000, then that would only be 10,000 minus 7,500 would be 2,500, right? I'm only paying the 17% tax on the amount over 7,500. That's fine. That's fine. Pagan, you want to help out with that?
I'm not really sure. Would it be like, yeah, I'm not really sure.
Okay. We'll pass it on here, Olivia.
So wait for the first box?
Right. So for the equation.
Wouldn't it just be 0.17x?
Okay, but it's not just X because you're not paying on your entire income. You're only paying on the part of your income over 7,500. See, that's the tricky part, isn't it? Wait, Andrew, you got your hand up. What do you think?
So I think it would be 0.17, and then in quotations you would do X minus 7,500, and then close the quotations and then say plus 825.
There you go. Yeah, good, right? Because we have 825 plus 17% of X minus 7,500, right? We're only taxing at that. Oops, I forgot the 17%. Darn it. Oh, I wonder if I did that for all of them. Yeah, I did. So we got to, I got to fix that. Let's do this. I'm just going to write on top of this thing. How about? Okay, so we get 825 plus 0.17 times X minus 7,500. Okay, and that's occurring in this part of the domain, right? So now how do we say this? If the taxable income is over 7,500, but not over 30,600, how would I say that, Olivia? So this is my domain. X is what?
X is greater than 7,500, but less than 30,600.
Okay, less than or equal to? Which one do you think?
Less than or equal to.
There you go, less than or equal to. Good. Okay. Next row. Natalie, what do you think? How am I going to do the next row? So if my taxable income is over 30,600 but not over 74,300, I pay 4,752 plus 25% of the excess over 30,600. So how am I going to say that? Kind of following that same pattern we were just doing. How about Maria? Okay.
4,352 plus 0.25 times 3,600.
Oops, why did I put 0.12? That's not what you said. 0.25 times x minus, what'd you say, Maria?
3,600.
Okay. Good. And then that would be our domain, wouldn't it? Okay. And then last one is a little bit easier. If your taxable income, well, I guess it's not that much easier. If your taxable income is over 74,300, you're paying 15,677 plus 31% of the excess over 74,300. It's just kind of the same pattern, isn't it? So now we're going to end up with, you're going to pay 15,677 plus 0.31 times the quantity x minus 74,300. And that would just be whenever x is greater than 74,300. Okay, so there's an example. There's an example of a real world piecewise function. That's when you would use a piecewise function. Okay. All right, and that's what it looks like if you plug all that stuff into Desmos. There's what it looks like. And this is kind of interesting. You can see that the slope of the line goes up a little bit for each of the different pieces, right? Which makes sense because the tax rate, which corresponds to the slope, is higher the bigger your income is. Okay? All right, I think I'm going to call her quits there and let you folks just kind of have at it. There's one more example here I was going to do, but there's actually a video on this one in the assignment. And so I think I'm just going to let you try your hand at it. I tried to put on this one, I tried to put some videos in. There are some questions that include some embedded videos, and at the start of each section, I tried to kind of find one like that. So if you want to, you can watch those videos. It's not necessary if you don't want to, but you might want to. I tell you what, let's just take a second and talk about this one. We only have to maybe write the function here, right? But let's just talk about this for a second. First class postage with a private postal service costs 29 cents for all weights through 1 ounce, plus 16 cents for each ounce or fraction of an ounce thereafter. Each letter is required to carry one 29-cent stamp and as many 16-cent stamps as necessary. Graph the function f that models the number of stamps y on a letter weighing x ounces. Okay. So if you have a letter that weighs 0.05 ounces, if that's possible, how many stamps are you going to need? Just show me fingers. You're going to need one, aren't you? Right? Anything, how about if you have a 1 ounce letter, how many stamps do you need? Right? It says all weights through 1 ounce, you have to have a 29-cent stamp. Right? So any weight that is less than or equal to 1 ounce, guaranteed you're putting one 29-cent stamp on the letter. Does that make sense? But as soon as what if it weighs 1.01 ounces? Then what do you have to do? It says plus 16 cents for each ounce or fraction of an ounce thereafter. Right? So you got one 29-cent stamp for the 1 ounce, and if you go over that even slightly, you've got to jump up to another stamp. It's only a 16-cent stamp, but you have to add a second stamp. Okay, what if your letter weighs 2 ounces? How many stamps do you need? You need 2. What if it weighs 2.01 ounces? How many do you need? You need 3. Good. What does this sound like? It sounds an awful lot like it, doesn't it? Only it's sort of the opposite, isn't it? Because this time, instead of rounding down, you're rounding up. Everybody see that? So this is what we call the greatest integer function is called a floor function. I'll just write this part down. I'm going to let you guys maybe do the rest on this one. Well, I'll tell you what, we'll do this. Why not? Why not? We'll do this. So let's look at this on the interval from 0 to 5. Okay. So we know that when the domain is greater than 0, and X is the weight in ounces, right? The output is number of stamps. When X is greater than 0 and less than or equal to 1, the number of stamps is 1, right? When X is greater than 1 and less than or equal to 2, the number of stamps is 2. Right? Now, if I were to graph this thing, what's it doing, though? This is a little bit different than what we saw last time, isn't it? Right? This time, instead of rounding down, we're rounding up, and so this is called a ceiling function. That's what we'd call this. Remember, we said that greatest integer function is synonymous with floor function. And that's where we're always rounding down to the nearest integer. This time we're rounding up to the next integer, okay? That ought to get you going on this maybe. All right, I'm going to let you work.